All right, so let us finish this one now. So for the RL mean, this is the formula given. Okay, then all you need to do is again get those given variables if they are available. Then once they're available, just substitute this one into here, and then just solve that one, and it will give us a result of 50 ohms. So meaning this is the minimum resistance that we can put with those given values. So you cannot go lower than that. Okay, so this is the standard with the use of this formula. And then for the RL max, so we have this one. First, find the IS and IL mean first. Okay, so IS is equal to VA minus VB divided by RS. So this one came from this formula. Okay, this IS right here. And then we have here the 15 volts as our VA, and then 5 volts as our as our VB voltage divided by the 100. Then solve that one will give us a result of 100 milliamps. So that is the current that we have in here for the IS. And then for the IL mean, we can use the formula of IS is equal to IZ right here plus IL. Okay, so we can have the IL mean is equal to IS minus IZM. Okay, so the only additional thing here is the IZM. IZM is the maximum current that can flow through a Zener diode at its rated Zener voltage, okay, which is 25 milliamps. So in here we have IS minus IZM. So we have 100 milliamps for our IS right here, and then we have 25 milliamps for our IZM, and that will give us a result of 75 milliamps as our minimum current. Okay, and then for the RL max, we have this formula. So RL max is equal to VZ divided by L. So this one is still Ohm's law. So VZ divided by IL mean is equal to 5 divided by 75 milliamps. Okay, and then those are the answers. Now, if this one is asking you to maybe find RL max or IL mean or IS instead of the minimum and maximum value of RL, then you can use those given formulas. So yeah, solving for the RL mean is like one step only. So you already have this given values, and then you now have the answer. But solving for the RL max, there's a few steps that you guys need to finish first before you can finally solve the RL max, which is 66.67 ohms. So in here, the minimum resistance that we can have is 50 ohms, and then the maximum resistance that we can have is 66.67. So you can go between 50 to 66.67. So other than that, is not good anymore for those values. Let's say 15, 100, and so on and so forth. Okay. So are we clear so far regarding with this one? Okay. So just to give you guys an idea on what is a voltage regulator, as long as you have that component, okay, or let's say circuit that can regulate your voltage, okay, or you can let's say control the voltage output, then that is already a voltage regulator. Okay, so in here, this is one of the simplest circuit of a voltage regulator. So you need two resistance, oops, two resistance, one Zener diode, and then your voltage input. Okay, so let's now proceed to example number 3, wherein Vs is the variable or the missing component. So we have to find the minimum and then the maximum value of your Vs. So IZM is still the same. You have 25 milliamps, but the value of your rated voltage and then the RL is now different. But the RS is still the same. Okay. So here is the formulas for the Vs mean and then the Vs max. So Vs mean is one step only. So as long as you know this formula, Vz times Rs plus RL divided by RL will give us a result of 9.33 volts. So this is the minimum voltage that we can put in here to make those other components work as a voltage regulator. And then for the VS max, so we have, you know, quite a few steps. So we need to find the IL and then the IS max. Then after those, then we can now solve for the VS max. Okay, so this one came from this, where is that one? Came from this formula. Okay, it's just shuffled wherein this VS max was transposed into the left side and then the rest were transposed into the right side. So with that, we can now solve the VS max. So I'll give you guys 1 minute to 2 minutes to recheck everything. So once you guys are already good, just give me thumbs up. So in your case right now, you guys won't be having a lot of problems in solving, this kind of problem, since this one is open notes. But before, when the first time that I taught this one in UC, so merong one sem na turo ako doon na naituro ko tong electro. And yun, ang problema nila is yung formulas. Because there's a lot of formula. So we have VS mean, VS max, IL mean, IL max, RL mean, RL max, IS mean, IS max, even though hindi naman siya given dito. Okay, as a variable, because the only three main variables that we can change in here is the VS, the RS, and then the RL. Okay, but we also have those IL mean, IL max, IS mean, IS max. So parang nakakalito talaga. Though some of them were able to get the correct answer, so I would say that they are really a genius. Okay, since they were able to maybe memorize everything, okay, with those given formulas. Okay, all right, so for the last example, we have here RS as your variable. So we have to find the RS mean and then the RS max. Okay, but before that, let's just go back here on the VS. So this is the minimum voltage that we can put in here, and then this is the maximum voltage that we can put in here. Okay, and then let's now find the RS mean and then the RS max. So for the RS max, so we have this given formula. So RL times VS minus VZ divided by VZ. Okay, so there is actually a pattern when it comes to those given formulas, though you don't need those patterns anymore since this one is open notes. Okay, so just maybe familiarize, okay, those steps, and then just go back here if you need the exact formula that you be needing. So RL is already given, VS is already given, and then VZ is already given. So just substitute everything, and then it will give you this result. And then in finding the RS mean, so again, we have to find the IL and then the IS max. So IL is equal to VZ divided by RL. So I think this one is very straightforward. Even though you don't have any basis, you already know that the one that we're looking for is the current of this, my bad, the current of this load resistance. So VZ is already given, and then RL is already given. So you can now find the current that is flowing on this RL. And then for the IS max, so this one is also quite straightforward. So all you do is add the current that is flowing in here and in here, then you'll be able to get the IS max. Okay, so that's 45 milliamps plus 0.0008 amps, which is the value of IL right here. So it will give us a result of 0.0458 amps. And then for the IS max right here, oops, okay. So IS max is already this one, but we can use this IS max formula. Okay, so this is another formula for IS max. We have VS minus VC divided by RS mean to get the value of your RS mean. So just arrange this one with this manner, okay, and then you will get 174.67 ohms. Okay, well, most of them were based on our main given formulas. So itong dalawang formula na to for IS. So that is where that one came from. So yeah, basically just memorize this general formulas, and then later on, after you familiarize everything on that one, then you can now proceed with the maybe the formulas for the RL mean, and then the RL max, VS mean, and then the VS max, and then RS max, and then the RS mean. Because the others, the IL, IS, and so on and so forth, they are already on this given formulas. Anyway, so are we clear with solution number 4? Okay, so for the reference, this one came from these two websites. Okay, this one came from electronic tutorials, and then some examples came from this YouTube link. Okay, if you guys need more example, then you can visit this website right here, or I think I posted a lot of. So you can check this 5 links right here. So 3 links for the Zener Diode, and then 2 links for the LPD. Okay, so we're not yet done. So we're just done with the module 6, but we're not yet done with the module 7. Okay, and then for the practice exercises, so uh, I did get a lot of external URLs where you guys can check. Okay, maybe what's the idea with the Zener diode, or what's the idea with this LED, okay, and so on and so forth. Okay, so just make sure to just check them out, and then if you need maybe more learnings, then oops, and of course you can check these reading materials right here. Okay, so we have this section B9 Zener diodes. This is actually a good PDF explaining the start of a Zener diode, and then Zener diode as a regulator. Okay, the unknowns, the VS, the series resistance, and so on and so forth. So everything is the same. Okay, and then this is the derivation on how did we get those formulas, like the RI, IZ max. Okay, although this one is quite long already, but yeah. And then we also have full wave Zener regulator. So if you only have enough time, then we'll talk about this full wave Zener regulator with capacitor now, okay, and then an inductor. So this one is quite hard already, okay. Though they'll be useful maybe if you'll work on the hardware industry or circuit industry. So especially that regulator is everywhere. Okay, yung voltage regulator na, yung EVR natin sa computer. So ito yung pinaka main idea, okay, kung paano nila maybe sinolve yung consistent voltage ng 220 volts and so on and so forth. Okay. All right, so any questions so far regarding with the Zener diode? Mr. Aizel, Mr. Marcangelo, Mr. Nathaniel, Mr. Macabio?
None heard.
All right then. So if you guys don't have a question anymore, then let's now proceed to the last module, which is the light emitting diode. So this one is super easy. So 13 slides only. So you guys already know the definition of an LED. So this is a specialized type of a diode. Okay, so that's why it's called light emitting diode. So it lights up a light. Okay, so this one is also, of course, the polarized. So we have a PN junction, so positive and then negative. So the same idea, it will only pass a current if it's in a forward bias or forward direction, then it will block the current completely if it's in a reverse bias direction. Okay. So when operated in forward bias direction, light emitting diodes or semiconductor devices that convert electrical energy into a light energy. Okay. And then this one, the shorter one is the negative one or the cathode, and then the longer one is the anode or the positive uh, side, okay, or the positive pin. Okay, so the identifier for that one is the flat spot, or just take a look of, on the pins itself. The longer one is the positive, and then the shorter one is the negative. Okay, so we also have this common anode RGB LED. So it has 4 pins. Wherein, of course, the first one is blue, green, and then the third one is the anode, and then the last one is the red. Okay, so that is where the RGB came from. So red, green, and then blue. Okay, so light emitting diodes are made from exotic semiconductor compounds such as gallium arsenide, gallium phosphide, gallium arsenide phosphide, silicon carbide, gallium indium nitride. So if you're going to mix them together, of course, with different ratios, you'll be able to come up with different colors, like maybe half of blue plus half of green. So to give you another color. Okay. So here are the wavelengths that you guys need to consider. So we have here, this gallium arsenide with this wavelength 850 to 940. So this one can produce an infrared color. And then this one only requires a 1.2 volt voltage. Okay. And it has, or it must have uh, a forward voltage, okay, of 1.2 volts at 20 milliamps only. Okay, so having a 1.2 volts is not enough if you only have, let's say, 5 milliamps of a current. So it should be consistently 20 milliamps. Okay, it seems that there is a question. No, no, no. Okay, so let me just read the question of Mr. Jean Alexis. So sir, bakit yung LED sa mga electric fans pag pinatay mo, susunod agad yung ilaw unlike sa TV? Is it because yung LED fan is indicators lang talaga? Okay, so yes, you're right that the LED on the electric fans are just indicators. Kapag sinaksak mo, mag-iilaw yon, and then pag tinanggal mo, mamamatay na rin kagad. So yung again, the reason why it's slowly dimming out is because of the capacitor. Okay. So maybe hindi lang nakakonect yung LED na yon kasi I think wala namang masyadong masisirang component. Okay, maybe on the electric fans. Unlike in TV, so it's a quite complex circuit. So that is why maybe there's a lot of capacitors. Okay, and then nagkataon lang na siguro naisama yung indicator ng sa TV. Though, pwede namang hindi kasama yung sa TV kahit, pag pinatay mo, mamawala na ng kagad yung ilaw. Pero mostly ganun lang yung case. Okay, so maybe sa loob pa ng or sa ibang circuit part ng electric fan, meron ding mga capacitor dun. So, hindi lang kasama yung sa LED. Okay? Alright, so one more thing. Oo nga rin pala. So, kaya din siguro kailangan ng LED ng capacitor is kapag patay sindi. Okay, if you guys will try to experiment using a breadboard, madaling mapupundi yung LED. Kasi lalo na kapag mabilis, patay, saksak, patay-patay, parang gano'n. Alam niyo na yung ibig sabihin. Kahit sa bulb, di ba, kapag ginagawa niyo yun sa switch, kapag ginawa niyo yan like maybe for 1 minute, so masisira yung bulb natin. Okay? So, yun yung purpose ng capacitor para hindi mabigla yung components natin. Okay. Oops. So, where are we now? So, gallium arsenide phosphide with this wavelength will give you a result of red, and so on and so forth. So, amber, yellow, green, blue, and white. And as you guys can see, kung i-compare nyo, magkakaroon tayo ng general conclusion how, white needs more voltage than the others. So, ito rin siguro yung reason kung bakit yung yellow light or yellow bulb natin, okay, sa mga bahay, yung unang-unang panahon, di ba, puro yellow yung mga bulbs natin. So, mas matipid kasi siya. Okay, daw. Pero hindi ko alam kung bakit yung sinasabi nila ngayon is the white one, which is the LED, yung tinatawag pa nilang LED. Okay, mas matipid na daw yun yan. Though, if that light is producing a white color, it says here that it requires 4 volts. But if it's yellow, then it requires 2.2 volts only. Alright, so they need different wavelengths in order to produce different colors. Of course, with different requirements of voltage. Okay, so the actual color of a light emitting diode is determined by the wavelength itself. Again, this one. Okay, of the light emitted, so which in turn is determined by the actual semiconductor compound used in the forming the PN junction during manufacture. So therefore, the color of the light emitted by an LED is not determined by the coloring of the LED's plastic body. Kasi parang yun yung tingin natin, okay, nakaberan lang ng plastic. Yun yung nagpo-produce ng kulay itself. Though, these are slightly colored to both enhance and the light output and to indicate its color. Okay. Kapag patay siya syempre kasi hindi naman natin makikita yung kulay kapag transparent lahat. So just to indicate that this one is red, okay, this one is blue, and so on and so forth. And at the same time, to enhance the color that it will produce. Okay. And again, by mixing together a variety of semiconductor metal and gas compounds, the following list of LEDs can be produced. Okay, so we have here gallium arsenide. Ito lang yung parang additional. Ito yung mga basic rather. And then ito yung parang lahat-lahat na. Okay, so we can have a emerald green. Okay, we have red and yellow with this gallium phosphide. We even have ultraviolet with this aluminum gallium nitride. Okay, so kung gusto niyo pang mag-create ng more variety of colors, then you can check those composition. Okay, so nagkaroon din tayo ng zinc selenide. Okay. Anyway, so we have here the most common LEDs. So most common LEDs require a forward operating voltage, which is 1.2 to 3.6. So ito yung common voltage ng mga LED, okay, na maliliit. Well, of course, kapag mas malaking LED, then it requires more higher voltage. Okay, and then the current that is ranging from this 1.2 to 3.6 is 10 to 30 milliamp. Though, ang common range daw, sabi dito, is 12 to 20 milliamps. Okay, though pwede kang mag-exceed ng 20. So you can have 10 to 30 milliamps depending on, the requirement of that LED. Alright? So the higher the voltage, then the more variety that you can have. Okay, as long as you have a consistent value of 20 milliamps. Kasi kahit let's say 4 volts na yung in-apply mo dito sa gallium arsenide phosphide, I think it's still safe, it's still okay. As long as hindi sobrang taas. Okay, though mas mabilis nga lang siyang masisira. Okay, or mas mabilis nga lang siyang mapupundi. Pero gagana pa rin sila. Okay, kasi by default, fix na mismo yung pinoproduce niyang kulay. Kahit na gawin mo 100 volts to, hindi na magbabago tong mga to kasi nagawa na sila as it is. Okay, with that composition of semiconductor. Okay, so that is why in batteries, yung mga 5 volts is already enough, or even 3 volts is already enough. Okay, so you can use with that range of voltage. So actually kahit 1 volt enough na kayo. Alright, so ito lang yung basic configuration. So we have the anode, positive, negative, cathode. So alam na alam nyo na to. Okay, so dapat dito yung flow of current natin from positive to negative in order for us to have a forward bias connection. Okay, and then here is the LED series resistor circuit. So dalawa lang naman yung kailangan yung intindihin. Well, yung position or yung placement ng resistor natin and then the voltage input or the voltage source. So dapat kung positive to, dapat dadali muna tong positive natin dito sa resistor. Okay? And then after that, it will pass through this positive pin of your LED. So wag na wag yung babalik na rin kasi mapupundi ka agad yung LED nyo. Baka sabihin nyo, baka pwedeng sa baba na lang yung resistor. No. Dapat nasa taas muna yung resistor natin and then sa baba yung LED. So with that, your LED will be safer from sudden fluctuation of your voltage source. Okay, and then we have here the one and only formula for this one in finding the series resistance. Okay, so Rs is equal to Vs minus Vf divided by If. Okay, so and here we're going to solve the value of Rs wherein we'll have a perfect let's say dito parang output or result of our LED. Alright, so let's have an example. So an amber colored LED with a forward voltage drop of 2 volts is to be connected to a 5.0 volts stabilized DC power supply. So using the circuit above, calculate the value of series resistor required to limit the forward current to less than 10 milliamps. So ang target natin dito is maximum of 20 milliamps. Well, pwede ka siguro mag-exceed. Pwede ka mag-experiment. Hindi naman masama na mag-exceed ka sa 20 milliamps since ang sinabi naman dito is 10 to 30 milliamps. Okay? But if you want a safer current that will flow, so 20 milliamp is like the safest one, I guess. Okay, since it can be handled by any kind of LEDs. But in here, in this question, it is asking us to limit the current into 10 milliamps only. So we should find that value of Rs. Okay. Number 2, also calculate the current flowing through the diode. Okay, if a 100 ohm series resistor is used instead of the calculated first value from the number 1. Okay, so here is the solution. So just simply use that formula and then substitute everything that is given. So Vs minus Vf, so 5 volts minus 2 volts divided by If, which is the our target current. Okay, so 2 volts given naman, voltage drop for the Vf, and then Vs is 5 volts. The 5 volts stabilized DC power. So just solve this one, then it will give us a result of 300 ohms. So meaning we need 300 ohms resistor right here in order for us to limit the current into 10 milliamps. So are we clear with this one? Any questions so far up to this point? Okay, so I guess none. And then for number 2, so calculate the current flowing through the diode if a 100 ohm resistor is going to be used instead of the 300 ohms. So just use this formula and then uh, make this one into something like this, or cross multiply nyo lang, and then you will get this IF equal to Vs minus Vf divided by Rs. So 5 minus 2 divided by 100, then it will give us 30 milliamp. So even though 100 ohms lang yung resistor natin, I think it's still safe, okay, according to this facts about LEDs. So 10 to 30 milliamp is the forward rating of the LED. All right. And then connecting LEDs together in series. So we can connect LEDs together in series to increase the number required or to increase the light level when used in displays. So as with series resistors, LEDs connected in series all have the same forward current. So dapat pare-pareha sila dapat. So positive, negative, positive, negative, positive, negative. Because if one of them were the other way around, so hindi na yung gagana case there is now a it's like an open circuit already since magiging reverse bias na. Okay, have the same work and then flowing through them as just one, and then as all the LEDs connected in series pass the same current, it is generally best if they are all of the same color or type. Okay, since we wanted to have a maybe a brighter color, so dapat pare-pareha sila. Well, pwede ka na mag-experiment. So, depende naman sa'yo. Okay, so this is just an advice that came from a book. And then connecting LEDs in series, so we have this results. So if we are going to add, or if you're going to combine 3 LEDs at the same time, so just multiply that 1 to 3, and then let's see the required 1.2 volts each. So the total that voltage that they will consume is 3.6 volts. Okay, and then solving for the RS, so we have this Vs minus VLED. Okay, so parang KVL lang, or wait, let me just check. RS is equal to Vs minus VLED. Vs minus VLED. Yeah, KVL lang. Since this one didn't came from this formula. Okay, because I was looking for the IF, but IF is not here. Okay, so for the RS, we have this 5. Wait a second. 5 minus 3.65 volts minus 3.6 is equal to 1.4 volts. I don't know if this one is incorrect since RS is series resistance, right? And this one should be a resistance. However, this one I is equal to V divided by R, and then V is equal to I times R. Anyway, so I'm not sure if this is a typo, but after solving this one is correct, which is 1.4 volts. So, and for the RS right here, we have V divided by RS is equal to Vs minus. Okay. So, pinagulo lang, separate lang. Okay. Ito yung IF natin mismo. Okay, which is the 10 milliamps. Okay. So this one came from here maybe. Okay, since hindi naman binigay yung 10 milliamps na given dito. So yeah, this RS right here is the this one is the numerator part, Vs minus VLED, and then this RS right here is now the complete version of this one. So after solving the Vs minus VLED, so we have 1.4 volts divided by 10 milliamps. So series resistance is 140 ohms. Okay, with a current of 10 milliamps. All right. So are we clear so far regarding with this one? So again, this one was separated into two. So numerator part, and then this is not the complete one. Anyway, these are the references for these module. And then if you guys need more information about LEDs, I think this one was already on the watch videos right here, these two links right here. So just check them out, okay? And yeah, that's it for the module 6 and 7. So any question or clarification so far? All right, so before I will answer your comment, Mr. Jean Alexis. So anyone who has a question or clarification? Yes, so there is no discussion next week anymore since we've already finished the module 6 and 7 today. Anyway, so let's have another meeting. I mean, yeah, kahit tapos na tayo dito, let's have another meeting for the part 3, just a short Zoom meeting because I'll be having an announcement to you guys. Okay? So I will answer your comment on the part 3, Mr. Jean Alexis, okay? Since we don't have enough time anymore. Okay, so goodbye for now and then see you guys later for my announcement.